Science isn't just facts, it's stories. Chlorine has one of the most confusing reputations in the entire periodic table. Because depending on where you find it, chlorine is either helping keep your drinking water safe, making your fries taste better, cleaning your pool, or absolutely bullying your favorite t-shirt. Same element, wildly different behavior. And that is why chlorine is so good. It is useful, reactive, misunderstood, and just dramatic enough to deserve its own episode. Chlorine is element 17 on the periodic table, and it belongs to the halogen family. That sounds fancy, but halogen basically means salt former, which is a very polite scientific way of saying this element loves attaching itself to other things and starting chemistry. In its pure form, chlorine is a yellow-green gas with a sharp, harsh smell. So right away, this is not one of the friendly-looking elements. This is not carbon quietly being useful. This is not neon minding its business in a sign. This is a green gas showing up like it has unresolved issues. The first thing to understand about chlorine is that the version people fear and the version people use every day are often not the same thing. That matters a lot, because chlorine gas is one thing. Chloride in table salt is another thing. Bleach is another thing. Pool chemistry is another thing. And if you mash them all together into one mental category called chlorine stuff, chemistry immediately files a complaint. Chlorine is reactive because it has 17 electrons and it really wants one more to fill out its outer shell. So it spends a lot of time trying to grab, share, or steal that last electron like a chemical goblin with a mission. And that single detail explains almost its entire personality. Chlorine is not stable enough to relax by itself. It wants to react. It needs to react. It lives to react. That is why chlorine is useful. And that is also why chlorine can become a problem very fast when it is in the wrong place, the wrong form, or the wrong amount. Science gives. Science also occasionally slaps you in the face. Let's start with the version of chlorine you know best, even if you never think about it. Salt. If you put salt on fries, chips, popcorn, or literally anything that tastes better after bad decisions, you are using sodium chloride. Yes, chlorine is part of table salt. That same sodium from the last episode, the one that is reactive enough to make chemists nervous, pairs up with chlorine, another reactive menace, and somehow together they become one of the most normal substances on Earth. That is chemistry being rude and amazing at the same time. On their own, sodium is highly reactive, and chlorine gas is harsh and dangerous. Put them together, and suddenly they are hanging out in your pantry acting innocent. That is one of the coolest things in all of chemistry. The properties of a compound can be completely different from the elements that made it. So when people hear chlorine and instantly think danger, they are missing the bigger picture. Because chlorine in chemistry is all about context. Same element, different form, completely different outcome. Meanwhile, chloride is not just something you sprinkle on food. Your body actually needs chloride ions. They help with fluid balance, nerve signaling, and digestion. Your stomach even uses hydrochloric acid to help break down food, which sounds extremely fake until you remember your body is basically a very advanced meat chemistry set. So chlorine is not just some industrial chaos gas. Part of it is helping you digest lunch. Meanwhile, in nature, chlorine usually does not hang around as pure elemental chlorine. It is too reactive for that. It usually shows up as chloride, locked into salts and minerals, especially in seawater and underground deposits. So a huge amount of Earth's chlorine is basically hiding in boring places wearing a fake mustache. The ocean is full of it. Salt beds are full of it. Minerals are full of it. Which means chlorine is not rare. It is just usually busy being chemically attached to something else. And when industry wants chlorine for useful work, it often gets it from brine, which is basically salty water. Using electricity, chemists can split that brine through the chlor-alkali process and produce chlorine, hydrogen, and sodium hydroxide. That one process is a massive deal, because from that point on, chlorine starts showing up everywhere in modern life. Water treatment, cleaners, plastics, paper processing, pharmaceuticals, manufacturing, infrastructure. So even if chlorine is not the star of your daily life, it is definitely somewhere backstage, running the whole production. Now let's talk about chlorine's best public relations move of all time. Water treatment. Chlorine helped make modern drinking water dramatically safer. And that is not some tiny side note. That is civilization level useful. When chlorine is added to water in controlled amounts, it helps disable or destroy many dangerous microbes that can spread disease. That means chlorine is one of the reasons millions of people can turn on a faucet and not immediately regret being alive. That is huge. It is honestly one of those boring miracles people forget to appreciate because once it works, it disappears into the background. Nobody turns on a faucet and whispers, "Thank you, chemistry." They just expect the water not to ruin their week. And fair enough. But chlorine deserves more credit than it gets. Here is the simple version of the chemistry. When chlorine is added to water, it can form hypochlorous acid. That compound is very good at attacking the inner machinery that microbes need to survive. So if bacteria are trying to start a side quest in your water supply, chlorine basically shows up like, "Not today." That same disinfecting power is also why chlorine is used in swimming pools. But now, we need to crush one of the biggest pool myths on Earth. That strong chlorine smell people notice around pools is not always a sign of extra clean water. In many cases, that harsh smell comes from chloramines. Those form when chlorine reacts with sweat, body oils, and yes, urine. So if a pool smells like it is trying to dissolve your eyebrows, that does not automatically mean the chlorine is doing a great job. It can mean the chemistry is getting messy, which is disgusting, but educational. And that is the kind of trade this channel makes. Chlorine also shows up in bleach, but again, chemistry refuses to let anything stay simple. Household bleach is usually sodium hypochlorite. That is not the same as pure chlorine gas. And that distinction matters because one of the fastest ways to sound confused in chemistry is to treat every chlorine-containing thing like it is the exact same substance. It is not. Elements are the building blocks. Compounds are the personalities. And chlorine has a lot of personalities. Some are useful, some are irritating, some will ruin fabric, some help keep cities functioning. That range is exactly what makes chlorine interesting. Chlorine belongs to the halogens, which includes fluorine, bromine, iodine, and astatine. This is basically the periodic table's dirt, one electron short, and emotionally intense group. Halogens are reactive nonmetals, and they are famous for how strongly they like grabbing electrons. Fluorine is the absolute maniac of the family. Iodine is calmer and feels more medically respectable. Chlorine lands in the middle, which is probably why it became so practical. It is reactive enough to be powerful, but manageable enough to use at scale. That is a pretty sweet career lane for an element. Chlorine was first produced in 1774 by Carl Wilhelm Scheele, although he did not realize it was a brand new element at the time. Then, in 1810, Humphrey Davy figured out that chlorine was in fact an element and named it from the Greek word for greenish yellow. So even chlorine's discovery story includes delayed recognition, confusion, and somebody else eventually getting the clean explanation. Classic science. And yes, chlorine also has a darker chapter. Chlorine gas was used in early chemical warfare during World War I, which showed in the worst possible way how dangerous chemistry becomes when humans decide to be absolute garbage with it. That part matters, because chemistry itself is not good or evil. It is power. Humans choose what to do with it. The same core understanding of chlorine can be used to sanitize water, disinfect surfaces, manufacture useful products, or do something horrific. That is not just a history footnote. That is a reminder that science gives people tools, not wisdom. Those are two different things. Meanwhile, back in normal life, chlorine keeps doing endless, boring, important work. It helps disinfect wastewater. It helps sanitize surfaces. It helps support hospitals, municipal water systems, and industrial processes. It helps make PVC, which shows up in pipes, flooring, cable, insulation, and all kinds of building materials. So chlorine is one of those elements that quietly holds up modern infrastructure while getting treated like the villain anytime somebody smells a public pool. That is rough. Let's go back to the electron thing one more time, because it really is the secret sauce here. Chlorine only needs one more electron to complete its outer shell. That I'm one away from being happy energy makes it extremely reactive. It is basically the periodic table version of someone lunging for the last open seat. When chlorine reacts with metals, it often forms salts. When it reacts in water, it can help form disinfecting chemicals. When it reacts where it should not, it can irritate tissue, damage materials, and create compounds you definitely do not want to freestyle with in your kitchen. And that last part is important, because chemistry is not a place for close enough. Mixing the wrong cleaning products is how people accidentally create very stupid problems. Chlorine chemistry is useful when controlled, not when somebody starts combining bottles under a sink like they are auditioning for a low-budget wizard movie. So what is the real lesson of chlorine? It is not chlorine is bad. It is not chlorine is good. It is that chemistry is all about form, context, and behavior. Chlorine gas is not the same as chloride. Chloride is not the same as bleach. Bleach is not the same as pool chemistry. And none of those should be talked about like they are one identical blob of chemical stuff. That is lazy. And chemistry hates lazy. Honestly, chlorine might be one of the best examples in the periodic table for why science gets misunderstood so often. People want easy labels. Safe, unsafe, natural, chemical, good, bad. But the real answer is usually more annoying and more interesting. It depends. It depends on structure. It depends on bonding. It depends on dose. It depends on what the element is reacting with. And chlorine is basically the king of making that point over and over again. If you want the best way to think about chlorine, here it is. Chlorine is the overqualified cleaner with anger issues. In the right dose, in the right form, in the right system, it is incredibly useful. In the wrong context, it becomes everybody's problem immediately. That is chlorine. Messy reputation, elite resume, terrible chill. So the next time you hear the word chlorine, do not just think pool chemical and move on. Think bigger. Think element 17, the greenish-yellow halogen that helps make salt, disinfects water, supports modern infrastructure, and spends its whole existence proving that chemistry is all about context. Chlorine is not here to be cute. It is here to react, solve problems, and occasionally wreck your laundry. Honestly, for an element, that is a pretty strong resume. And if you thought chlorine was interesting, just wait until you see what the rest of the periodic table has been hiding.